second half of 12.3, we're doing more analyzing of geometric sequences. All right, so if you'll remember, the rule for a geometric sequence is the first term times the common ratio raised to the n minus 1 power. So we're going to need to know that, because the first thing I want you to do is I'm going to give you two terms within the sequence, and I want you to find the rule. What is the rule for this sequence? Well, again, just like we did with the arithmetic sequences, we can use two equations with two unknowns in order to find this, because we don't know the ratio and we don't know the first term, but we do know two terms. So let's put the equations in. So the third term is 45, and that equals the first term times the ratio to the n minus 1 power. So this is 3. This is the third term, so 3 minus 1 should be the 2 power. All right, and then we've got a to the fifth is 405 equals the first term times the ratio raised to the 5 minus 1 is the fourth power. All right, and so now what we can do is, in this case, I think I'm going to move this over here, because because these aren't added, we can't eliminate them necessarily, but what we could do is this. What we can do is, with each of these separately, let's solve for this first term, and then we can set those equal. We can use substitution. So divide by r squared here, and divide by r to the fourth here. So now we've got our first term equals this, and our first term equals this. So now we have 45 over r squared equals 405 over r to the fourth. And now we can just solve for r. So if we multiply both sides by r squared, we get rid of that denominator and we reduce that down to r squared. And now we can use cross multiplication. So r squared times 45, 45 r squared equals 405. Divide by 45. Let's see. I don't think I did that part. And 45 is what? 9? Is that right? 9 times 5 is 45. 4 times 4. 9 to 36. Yes. Okay. And so now to take the square root. So we've got r equals 3. So now we put that back up into something. Let's put it up into this one, so then we can find out what the first term is. So 45 equals first term times 3 squared. 3 squared is 9, so divide by 9. And our first term is 5. So now we have the pieces that we need. So what you're going to do is set up two equations with two unknowns, solve for one by using either side. In this case, you're going to probably end up using substitution each time, because you're going to be multiplying there. That's the way the formula works. So now just plug that in to our rule, and that's what we're trying to do, is find the rule. So a sub n is going to equal the first term, which is 5, times the ratio, which is 3, raised to the n minus 1 power. And that's all we're looking for. All right, you can do it. All right, the next thing that we're going to do with this is that we do also want to do series. And if you'll remember, with the series, that's adding each of the terms in the sequence. That's what makes it a series. I have a formula for the sum of the numbers in a series is simply the first term times the quantity of 1 minus the ratio raised to the term power divided by 1 minus the ratio. All right, so what you can do is, if you've got those parts and pieces, if you want to know the sum of this geometric sequence, you've got all the pieces. All right, if you've got a summation notation, you've got all the pieces to actually plug into this formula. So what we want is, we want the sum of 6. So we're going to say this sum is the first term. And remember, you can get the first term and the ratio directly from the rule. The first term is that first number, and the ratio is the number that's raised to the power. So you're going to take the first term, which is 4, and you're going to take that times 1 minus the ratio, which is 3/2, and you're going to raise that to the n power, and the n power is 6. Did you see where I got this 6? I want the first 6 terms. That's where this comes from. All right, and then we're going to divide by 1 minus the ratio again, which is 3/2. And you say, well, how do we do that? Wait, you can do it. Here's what we're going to do. We're going to simplify. You're going to have 1 minus 3 to the 6th power is 729. And 2 to the 6th power is, I believe, 64. And you're going to put that over 1 minus 3/2, which is -1/2. And then you're going to take, you can simplify this down. 1 minus, this is 64. So 64 over 64 minus 729 over 64. So 729 minus, you're going to end up with a negative number. 725 minus 64 gives you 665. 9, 6, 6, or 12, yes. Okay, so now you have, don't lose your 4, and you've got what's on top is going to be, oh, we did that, 1 minus this, so it's going to be -665 over 64, and you're going to divide by -1/2, which means you're going to multiply by the reciprocal. So you're going to multiply by a -2 over 1. So now we've got a negative, and a negative is a positive. Divide by 2 is 32. Yeah, divide by 2 is 32, and I did that wrong in my notes, so I'm very glad that I did that. Oh, no, I did it. I didn't do it wrong on my notes. Okay, so we've got 665 over 32. Duh, we got to multiply by the 4. So now we've got 4 over 1 times 665 over 32. Now it's going to work. Now we divide by 4, and we get 8, and so our final answer is 665 over 8, and we're done. Phew! All right. Sometimes I wish I had a quick pause edit so that when I make silly mistakes like that, you don't have to replay them over and over. Okay, here we go. Let's do a word problem and then be done. All right, in 1999 in Maryland, about 586,000 used cars were sold. From the year 1999 to 2004, the number of used cars that were sold in Maryland increased by, oh, look at there, increased by, talk about errors. Okay, increased by about 3.8% each year. So what I want you to do is 2 steps. First step is I want you to find a rule for the number of cars that were sold, and I want you to give that rule in terms of the years, and you can use n equals 1 is 1999. Then I want you to tell me the total number of cars that were used cars that were sold in Maryland from 1999 to 2004. So what we need to do is just take this general information and put it into our rules and into our formulas that we already know. So I'm going to scooch it over this way first to remember the rule. So A, we want the rule for the total number of cars sold. So let's look and see. We've got a to the n equals a, or a sub n. Here, let's just put it. A sub n equals first term times the ratio raised to the n minus 1 power. So what's going to happen is this. We want the first term, and we said the first term is 1999, and we know that in 1999, 586,000 used cars were sold. What we can do is just leave it 586, and then remember in our final answer, this is in terms of thousands. So we're going to multiply by 1,000 at the very end. So 586 is our first term, and then we're going to increase it by a ratio. And now watch this. The ratio is not just the 3.8%, because it increased by 3.8%. So not only do you have the 3.8%, but you also have however many were already there. So if there is an increase of this, you're actually going to multiply, your ratio is going to be 1.038. Because 3.8 was your percent, and you're going to change that to a decimal, which is 0.038. And then we have to also add in the cars that were sold before. Remember, when you're multiplying, you're in this case, you're increasing. All right. And then you're going to have the n minus 1 to the n minus 1 power. And we're just looking for the rule, so we're done. All right. So B, now what I want to do is I want the total sold from 1999 to 2004. So now this is not just, I don't want just the total in one specific year. If I wanted 3 years from now, then I would work up a sub 3, right? The third term. But this, since I want a sum, I want to use this equation. All right, I want to use the summation equals A1 minus R to the n over 1 minus R. All right, so now, once again, I can just plug in what I know. So this is going to be the sum of how many years? Well, we've got 1999, 2000, 2001, 2002, 2003, 2004. I've got 6 years included in this total. So I'm going to do the summation of 6. The summation of 6 years. And that's going to equal the first term, which is the 586. And then I'm going to put in 1 minus my rate. And you remember your rate is this 1.038 raised to the n power, which is 6. And I'm going to take that over 1 minus 1.038. And this I'm going to leave to you and your lovely calculators. I will promise you that my answer is right because I worked it and worked it and worked it. All right, you're going to take this to the 6th power. And then you're going to take 1 minus what you got there. And then you're going to divide it by, well, this is 1 minus this just gives you the 0.038. So divide by that on the bottom. And you should end up with 3 million cars. 3,867,000 cars. Because remember, this is the answer I got, 3,867. And remember, our answer is in thousands. All right? No problem. So that's how you actually use those formulas in your word problems. See you next time.